Today we are going to talk about solving equations, but in particular we're going to be talking about solving quadratic equations. That is, solving equations that have an x squared in them. So the first equation we're going to solve is x squared minus 25 equals 0. And until recently, we would have probably solved this equation using factoring. For example, this is a difference of squares, so we can factor x plus 5, which is the square root of 25, and x minus 5 equals 0. And then we would solve because this is a product, so we would use what's called the zero product property. We would set each of these factors equal to 0. So for example, x plus 5 equals 0, and x minus 5 equals 0, and we would get two solutions. X equals negative 5. If I subtract 5 from both sides, I get x equals negative 5. And over here, I would add 5 to both sides to get that x equals positive 5. So we have two solutions, x equals negative 5 and x equals positive 5. And those would be our solutions to this equation. And just like I'd said before, I'm going to hold myself to the standard that I put that in set notation. So the solution to this equation is x equals plus and minus 5. So that would be the solution. However, factoring is not the only way to solve quadratic equations. So we are still solving quadratic equations. There are actually 4 methods of solving quadratic equations. The first is factoring and setting each piece equal to 0, which again, I mentioned is called the zero product property. Some textbooks refer to this as the zero product property quite frequently. Others maybe only mention at the beginning, but if you want to look it up later, zero product property will be what it's referred to as. We can also use a few other tools, including what we're going to be talking about for this particular lesson, which is the square root property. And 2 other methods, which we'll talk about later, are completing the square and the quadratic formula, which is probably the first thing people actually think of when they go to solve a quadratic equation. So once again, we solved x squared minus 25 equals 0 in the past by factoring, and we got 2 solutions, positive and negative 5. But seeing this x squared here, it's just a squared. Maybe I can ask myself, well, what undoes a squared? Well, a square root undoes a squared. So maybe I can get that squared by itself and try to use a square root. So I'll add 25 to both sides. And then I'll end up with x squared equals 25. I want to undo the squared. So to undo the squared, I'm going to use a square root. square root both sides, square root of x and the square root of 25. But remember, before we had two solutions, positive and negative 5. So in order to get both the positive and negative version, we're going to be using both a plus and a minus when I take a square root in an equation. So whenever I take a square root in an equation, remember the plus or minus. So square and square root cancel out. We're left with x here equals the square root of 25 is 5 plus and minus versions. So once again, I put my solution in set notation, plus and minus 5. So that is the square root property. We can do a couple more examples of this. So for example here, if I have the equation 4x squared equals 49, once again I have an x squared right here. So maybe I can try to factor if I want to, but again, since I have this x squared almost by itself, square root property might be a better way. So let's get the x squared by itself. The 4 is attached by multiplication. So to get rid of it, multiplication. So to get rid of it, I'm going to just divide it away. That's going to leave me with x squared equals 49 over 4. Okay, now to undo the square, I'm going to take a square root. Whatever I do to one side, I'll do to the other. And don't forget, when I'm taking square roots in an equation, I'm going to plus or minus. Now, square and square root cancel out, so I'm left with x equals plus or minus. And if you remember the rules from before for dealing with exponents and for dealing with square roots, because square roots are just an exponent, I can take the square root of the numerator of the top, square root of the denominator of the bottom, and this is going to leave me with x equals plus or minus square root of 49 on top, which is 7, square root of 4 on the bottom, which is 2. So now we have x equals, again, 2 solutions because this is a quadratic equation. I can have up to 2 solutions. And I'm going to put that in set notation, plus or minus 7/2. All right, one more example to talk about. Sometimes when I take a square root, I end up needing to take a square root of a negative number. For example, if I want to take the square root of -1, you guys remember the square root of -1 is just I. So that is potentially going to come into play here with this last example. So here we have one more example here.
Ain't no souls here.
I have x minus 5 squared plus 4 equals 0. And again, I'm going to try to use a square root to get rid of anything that is squared. So I'm going to get the squared by itself first. So subtract 4 from both sides. That's going to give me x minus 5 squared equals -4. Take a square root to get rid of the square. And whenever I take a square root, I'm going to plus or minus. So we have square and square root cancel out. I'm left with x minus 5. On the other side, I have plus or minus the square root of -4. So I have x minus 5 equals plus or minus. I'm going to split this into the square root of 4 times the square root of negative 1. X minus 5 equals plus or minus, square root of 4 is 2, square root of negative 1 is I. And finally, to get x by itself, I'll just add 5 to both sides. Gives me x equals 5 plus or minus 2i. So you'll notice my answer is in a plus bi form. And I can put this again in set notation, 5 plus or minus 2i. Two different solutions here, the plus version and the minus version. And that is how we solve equations using the square root property.